Namaste and welcome back to JEE Physics with Typical Monk. This is class 24, Wave Optics. Ray optics could never explain the colors in a soap bubble or the bright and dark bands behind two thin slits. For those, light must be a wave, and two waves can add or cancel. Where crest meets crest, light brightens. Where crest meets trough, it vanishes. That single idea, interference, gave the first true proof that light is a wave and it measures a wavelength smaller than a hair is wide. Today, Huygens, Young's double slit, fringe width, diffraction, and thin films. One idea at a time. Here is what you will master today. First, Huygens principle and wavefronts. Second, interference and Young's double slit. Third, fringe width and coherence. Fourth, diffraction at a single slit. And fifth, thin films, resolving power, and the drills. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. Huygens principle. Every point on a wavefront is itself a source of secondary wavelets. Interference. Two coherent waves overlap, crest on crest brightens, and crest on trough cancels. The condition. It is constructive when the path difference is a whole number of wavelengths and destructive at a half integer. Master line. Ray optics could not see this. Only waves interfere and diffract. Now look at the picture. Young's double slit experiment. The setup. Light passes through two closed slits, 1 and S2. It spreads from each and overlaps on a distant screen. Path difference. For a point on the screen, the difference in the two path lengths is d sine theta, and for small angles, approximately d times y over d. Bright and dark. It is bright where the path difference is n lambda, and dark where it is a half integer of lambda. Coherence. The two slits act as coherent sources because they are lit by one and the same original wave. Now, the single most important number here, the fringe width. Definition. The spacing between two adjacent bright or two adjacent dark fringes is beta. The formula. Beta equals lambda d over d, the wavelength, times the screen distance divided by the slit separation. What changes it? The fringes are wider with a longer wavelength or a larger screen distance d, and narrower with a bigger slit separation d. Equal and bright. In interference, all the fringes are equally spaced and equally bright. Now, the requirement that makes it all possible. Coherence. Coherence. The two sources must keep a constant phase difference, otherwise, there is no steady pattern at all. Two independent bulbs never interfere, their phases jitter randomly, millions of times a second. The trick. You must split one wave into two, as Young did, using a single slit before the double slit. Constructive. When the path difference is n lambda, the waves arrive in phase and brighten. Destructive. When the path difference is n plus a half times lambda, the waves arrive out of phase and cancel. Now look at the picture. The interference pattern itself. The pattern. A row of equally spaced, equally bright fringes marching across the screen. Fringe width. Beta equals lambda d over d is the distance between two neighboring bright bands. The center. The center fringe at zero path difference is bright. Versus diffraction. By contrast, single slit diffraction gives a central maximum twice as wide as all the rest. Now, diffraction and the colors of thin films. Diffraction. Light bends around an edge or through a single slit, spreading out into a pattern. The single slit. It gives a broad, bright central maximum, with dimmer maxima on either side. The central width. That central maximum is twice as wide as the side ones, and its half angle is lambda over a, the wavelength over the slit width. Thin films. The shifting colors in a soap bubble or an oil film come from the interference of light reflected off the two surfaces. Resolving power. Diffraction sets the ultimate limit on how finely any instrument can separate two nearby points. Now the formulas that earn marks. Fringe width, beta, equals lambda d over d. Bright and dark. The path difference is n lambda for a bright fringe and n plus a half times lambda for a dark one. Single slit minima. They occur where a sine theta equals n lambda. Now match each formula to its meaning. Beta equals lambda d over d goes to the fringe width. A path difference of n lambda goes to constructive, a bright fringe. Huygens goes to a wavefront of secondary wavelets. And a sine theta equals n lambda goes to the single slit minimum. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The fringe width is lambda d over d correct. Statement 2. Two independent bulbs produce a steady interference pattern. Wrong. They are not coherent. Statement 3. The central maximum in single-slit diffraction is the widest. Correct. So the answer, 2 are correct. Statements 1 and 3. The trap is the incoherent bulbs in statement 2. Now the 2 mistakes that quietly cost marks. The truth. Interference needs 2 coherent sources, split from one original wave. The trap. Thinking 2 separate bulbs can interfere. Their phases jitter randomly. The second truth, the fringe width, is beta equals lambda d over d, wider for a longer wavelength. The second trap, using n lambda for the dark fringes, destructive interference needs n plus a half times lambda. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The fringe width formula, beta equals lambda d over d. Question 2. Constructive interference needs a path difference of a whole number of wavelengths, n lambda. Question 3. 2 slits lit from one source are coherent. Question 4. The single slit central maximum compared to the others, twice as wide. And question 5. By Huygens, every wavefront point is a source of secondary wavelets. Let us gather it all in one breath. Huygens, wavefronts made of secondary wavelets. Young's double slit, a path difference of d sine theta, bright at n lambda, dark at n plus a half, times lambda. The fringe width, beta equals lambda d over d, equal and bright fringes. Coherence, one source split in 2, independent bulbs never interfere. Diffraction, the single slit central maximum, twice as wide, plus thin films and resolving power. Next class, the dual nature of matter, the photoelectric effect, and the Broglie waves. 2 waves, split from one, can meet and either blaze or vanish. And in that simple fact lies the proof that light is a wave and a ruler fine enough to measure a wavelength. Hold the double-slit geometry, the fringe width lambda d over d, the demand for coherence, and the wide center band of diffraction. Next class, the strangest turn of all, matter itself behaves as a wave and light as a particle. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack JEE. I will see you in the next class.